Hi, Assalamualaikum. Greetings to everyone. Today, me, Muhammad Ilyasa bin Muhammad Aziz, matrix number 009 DEE2F 2001, and my friend will present our first presentation. We will talk about meaning of differentiation, application, solution, Q&A section, and conclusion. First thing is, what is differentiation? Differentiation in mathematics process of finding the derivative or rate of change of a function. In contrast, to the abstract nature of the theory behind it, the practical technique of differentiation can be carried out by purely algebraic manipulation using 3 basic derivatives, 4 rules of operation, and knowledge of how to manipulate function. The 3 basic derivatives are: the first one is algebraic function. Algebraic function is x power of n equal to nx power of n minus 1, in which it is a real number. The second one is trigonometric function. Trigonometric function equal to sin x equal to cos x, and cos x equal to negative sin x. And the third one is exponential function equal to exponent power of x equal to exponent power of x. For function bulk or combination of these classes of function, the theory provided the following basic rule. For differentiation to some product or quotient of any two function, that it is x and gx, the derivative. The other basic rule, called the change rule, provide a way to differentiate a composite function.
Thank you to Ilyasa for his presentation. Now, I will continue the presentation for my part about application of differentiation. My name is Muhammad Shafiq bin Masha. My matrix number is 09DE20F2024.
The contents of this template is about what I will present for our presentation. It is about introduction to application of differentiation. The first point is, differentiation can help us solve many types of real world problems from the side of in the engineering sector, carpentry, and business. The second point is, the process of finding maximum or minimum values is called optimization. Next, from industry sector, we are trying to do things like maximize the profit in a company or minimize the cost of or find the least amount of material to make a particular object. This point is very important in the world of industry. For example, in business world, there are many applications for derivative. As application, when the data is entered to a data table on Excel. The second point is about a graph can be sketched with the application of differentiation. From the graph, we can see, estimate, and analyze the profit or loss for the data.
Thank you to Shafiq with his presentation. Next, Assalamualaikum and greetings to all. My name is Iqmal Fidaus bin Kasikin. My matrix number is 09DEE20F2008, and I will present my part, which is Q&A session and mathematical solution with drawings. So we move to the questions. An engineer has to build a bridge to allow the river underneath the bridge to flow. Given an equation of y equals to negative x squared minus 4x plus 5, the engineer has to find the maximum height of the top of the bridge from the river below it for a safe bridge height for a car usage. Next, we can see this is the bridge picture. So this is not a real picture of the bridge, so this is an example only because the bridge is not drawn with an actual height or measurement. So we can see this is the sketch of the bridge. On the top of the sketch, that is the maximum point of the bridge, and we can find any other point on the bridge with the given equation. For the first step is write down the given equation and differentiate it. So I already write the equation, which is y equals to negative x squared minus 4x plus 5. So we differentiate the equation, we will get negative 2x minus 4. So the x power of 2, so the 2 we will bring to the front, so it will be negative 2x. So the power of 2, we will subtract it with 1 because that is the law of differentiation. So next, the negative 4x, we will differentiate it and it will become negative 4 and 5. If we differentiate 5, we will get 0, so I didn't write it. So the final differentiated equation is dy over dx is equal to negative 2x minus 4. Next, we move to the second step, which is we will equal the differentiated equation with 0 to obtain the x coordinates. So dy over dx is equal to 0. So the differentiated equation is negative 2x minus 4, which I already calculated. So negative 2x minus 4 is equal to 0. So we will make the x as the main subject here. So negative 2x minus 4 is equal to 0. So we will bring negative 4 to the right side, which is negative 2x is equals to 4. So we will make the x as a subject. So x equals to negative 2, which 4 is divided by negative 2, we will get negative 2. So now we already get the x coordinates. So next, how to get the y coordinates? Next, we will substitute the x coordinate, which is negative 2. I already calculated at the upfront. So we will substitute the x value to the original equation to obtain the value of y. So the original equation is y equals to negative x squared minus 4x plus 5. So we will substitute x is equal to negative 2 to the equation. So y equals to negative y equals to negative multiplied by negative 2 minus 4 times negative 2 plus 5. So the final answer for y coordinate is 9. So we can see here the x coordinate is negative 2 and y coordinate is 9. Next, we move to the third step. How to determine the point we already get, whether it is a minimum point or maximum point for this equation. So determine whether the x coordinate is minimum or maximum value by double differentiate the first differentiated equation. So the first differentiated equation is dy over dx is equal to negative 2x minus 4. So we differentiate the negative 2x minus 4. So we will get negative 2. Why negative 2? So negative 2x, when we differentiate it, we will get negative 2, and negative 4, if we differentiate negative 4, we will get 0. So the final answer is negative 2. So negative 2 is less than 0. So negative 2 is maximum point. So negative 2 and 9, negative 2 is for x coordinate and 9 is for y coordinate, is maximum point in this case. So we will, as you can see at the bottom, this is the law. When d squared y over dx squared less than 0, it will give maximum point. So next, when d squared y over dx squared is equal to 0, it indicates the coordinate is inflection point. Next, when d squared y over dx squared is greater than 0, so the coordinate shown is minimum point. So we already arrived to the fourth step, which is we will find the other coordinate for the graph. So this is the table which I already calculated, and when x coordinate is negative 5, we can see there y coordinate is 0. How we will get this table? So we use the original equation. So we will substitute the x value to the equation. So we will get the y coordinates. So this is the final step. We already get the coordinate, we already get the maximum or minimum point. So in this graph plotting, we can prove that negative 2 for the x coordinate and 9 for the y coordinate is a maximum point. Hence, the engineer that have to build the bridge already found a bridge scale to build according the graph sketch that show the maximum point graph and looks like a tunnel. So in this situation, the engineer that have to solve this problem already found a solution for his problem. So you can see the graph is looking like a set graph. So when a set graph, it shows a maximum value. So how I can plot this graph, we can see back at the fourth step. So I already calculated when x is equals to 0, what is the y coordinate. So I already implemented the solution to this graph. So I already success to draw a graph for this equation.
Thank you Iqmal for the presentation. My name is Muhammad Fakhri bin Magani and my metric number is 09DEE20F2033. Now we already reached the final part, which is the conclusion. As conclusion, student must be learn differentiation because it gives many applications in real life. As for example, in business sector we can find maximum and minimum profit. Then differentiation is easy if we truly understand the basic. Once the basic is already mastered, we can apply it to real life situation like engineering purpose or business purpose. Thank you for watching. That's all from us. Have a good day. Bye.